Here we have the periodic heat flow through a building. We've got to imagine that we've got the outside skin of the wall represented by this solid line here. We're not told the thickness of the wall nor the composition of this wall, but let's assume it's a typical suburban brick veneer. So we've got the outside skin of the brickwork, we've got the 40mm gap, and then we've got the timber frame with the gyprock wall. How long does the heat take to travel from the outside to the inside? And so on this dash 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 line, we have the internal air temperature on the internal skin of that composition wall. At the middle of the day, the outside air temperature is rising. So here we have 12 o'clock. The outside temperature on the brick wall might not reach its peak till, say, 2 o'clock in the afternoon. The temperature drops externally as time progresses. Here we have 6 o'clock. Here we have midnight. It takes some time for that heat load to get through the typical brick veneer construction. You've got the brick wall, you've got the 40mm gap, and then you've got the skin of gyprock. The peak is here at 2. The peak isn't here till about 10 o'clock at night. The time lag that it takes for the heat to get through the wall is represented by this. But we also need to note that there is a temperature drop. The temperature drop is from here to here. And we can expect that. We have a lot of energy lost travelling through the brick wall. We have a lot of energy lost through the air gap of 40 mils. And we have further temperature loss through the gyprock wall. We then need to represent this. The term we use is the decrement factor. The decrement factor is a representation of the temperature difference between maximum and minimum outside and the maximum and minimum inside. So we have Ti, which is the internal temperature between the peak here and the trough here, and the outside, which is the peak here and the trough here. So the decrement factor is Ti over To. Usually in brick veneer construction, we introduce some insulation. The insulation also increases the temperature drop. And so every wall configuration has a different decrement factor. It's never 1, because if the decrement factor was 1, then the outside air temperature would eventually be achieved internally. We don't want that, and we don't allow it to occur in our building design. And so that's why we use brick, we use gyprock, we use some form of insulation, and the air gap is also important between the outside skin and the inside skin of the wall. Now, the reason why this is important is we want to design our buildings so that we are adequate and we feel comfortable internally. At the middle of the day, when the outside air temperature, let's say, might be 40 degrees, we want to feel comfortable. And so the internal temperature might be, let's say, 20 degrees. By the time the temperature has dropped to 20 degrees, internally it's risen to a comfortable 30 degrees, let's say. And so consequently, we have a comfortable zone within the building. The decrement factor is derived for various wall configurations. It's based on the maximum and the minimum between the outside and the inside. Ti over To.